So on Friday, we examined how to read and interpret data. Today, we're going to kind of go a little bit more in depth with that. We're going to be able to identify the shape of the data, and that's going to allow us to interpret it in a special way. Okay? So first off, if something is symmetrical or symmetric, it's evenly distributed. It creates kind of like a bell shape. Okay, the intervals are evenly spaced. It doesn't have to be perfectly symmetric. It will have only one peak, and all the data will be in close range of each other. There's no data that's like an outlier that's further away. Okay. When it's in a bar graph or a histogram or a dot plot, it traditionally looks like a bell. When it's in a box and whisker plot, the quartiles are evenly about the same, okay? If it's not the same, then that's when we have a different type of shape, which we have one right here, which is positively skewed. It's also known as right skewed. The large portion of the data is on the left. It's because the outlier or the number that is causing the data to be skewed is the higher number. Okay, for example, here you see how this quartile is larger, so that makes it positively skewed because the number is further away that's skewing it. Okay, the larger number. Okay, and the other direction, negatively skewed, is also known as left skewed. The large portion of the data is on the right. It means that there's a lower number that's skewing the data. Okay. And then there's some other shapes, which are like a bimodal. It has two peaks. A multi-data has multiple peaks. And a uniform data is all the same. And I would draw lines so that you can know which one belongs to which. So let's look at some examples to identify. Okay, identify the shape of each distribution. So figure A, we think it is negatively skewed. How about B? Symmetric. C? D? I would do bi because it only has two. If it was three, then it would be multi. Bimodal. And E? Uniform. Alright, so now what we're going to do is after we identify the shape, we're going to determine the measure of central tendency and its variability. So central tendencies are the center numbers. Those are our mean, median, and mode. And our spreads are our range, IQR, and standard deviation. All right, if it's symmetrical, we are going to only find, and it's asking us to identify the shape and then identify the center and spread, then we are going to find the mean and standard deviation, okay? So if it's symmetric, we're finding the mean and standard deviation. All others, we are finding the median and the IQR. Okay, you have to find the mean in order to find the standard deviation, so that's a good way to remember that. And you have to find the median in order to find the IQR, so that's a pretty good way to remember that one. Okay? Okay, the data shows the number of state students in the 12th grade social studies class have visited. Create a data display and choose the appropriate measure of center and spread to describe the distribution. Okay, so I'm going to first list my numbers from least to greatest, and then we are going to create a data display. So I'm going to list all my numbers. So I have 10, 10, 10, 11, 11, 11, 4 11s, 2, 3, 4, 5, 6 12, and 3 13s, a 14, and a 19. Alright, so we have multiples of each number, and they're not intervals. So we can either create a bar graph or a dot plot. Those would be probably the best to see the shape of the data. Okay, which one do you guys want to do? Probably dot plot, because they're the easier ones. Okay, so we're going from 10 to 19. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, I have 3 10s, 4 11s, 6 12s, 3 13s, 1 14, and 1 19. All right. So, what type of distribution is this? Positively skewed because of the 19. If the 19 wasn't there, then it would be symmetric. But because the 19 is skewing my data, it's going to change my range. Think about it like that, changing your range. If it's going to change your range, then it's either negative or positive. So that's going to be positively skewed. So I have to find the median and the IQR, because it's all others, it's not symmetric. Alright, so let's find our median. The median's pretty easy to find. We can cross off numbers until we get to the middle. And we have 2, but they're both 12, so it's 12. Okay, and then our IQR, we have to find our upper quartile and our lower quartile. So my upper quartile, I can find the median of that, which is 13, minus our lower, which is 11, and we get 2. Okay, so choose the appropriate measure to describe the center and spread of the data. Explain what those measures mean, or the meaning of those measures. Okay, so do I have any data that's like really far away from it? There's an outlier number here? No, not really. All my numbers are within 5 to 9. There isn't really like any big spread out numbers. Maybe if these 8s weren't there, it would be positively skewed, but because they are there, it makes it symmetric, okay? So this is symmetric, and because it's symmetric, what do I have to find? Mean and standard deviation. Symmetric, so let's find our mean. So I'm going to take all of my numbers and I'm going to add them up. You could put the numbers on top, so I can have 5, 5.5, 6 times 3 is 18, 6.5 times 4 is 6.5 times 4. 20 or 6.5 times 4. It's an even number. 26. 7 times 2?
14,
8 times 2?
16.
9 times 1? Alright. So let's add this all up. $93.5. And we divide that by how many numbers there are, which there are 14. We're going to get what?
6.6.
I mean, we're at 6.7. And what does the mean tell us?
Let's see.
What does the mean mean? The average. Alright, so what goes with mean? Standard deviation. I know you guys were so excited about me. So standard deviation, so we have to take each number,
Multiply by
subtract the mean, and square it, okay? So 5 minus 6.7 squared is going to be 2.89. And 5.5 minus 6.7 squared is 1.44. And then we're going to do 6 minus 6.7 squared is 0.49. And there are 3 of those. Okay, 6.5 minus 6.7 squared is 0.04. And there are 4 of those. And 7 minus 6.7 squared is 0.09. And there are 2 of them. And 8 minus 6.7 then squared is 1.69. And there are 2 of them. And last, 9 minus 6.7 squared is 5.29. So we need to take all of those numbers and add them up. So some people in my other class periods were getting incorrect numbers and adding them. So what you can do, and if you have multiples, so you're less likely to make a mistake, you can take however many multiples you have and multiply those first. So if we take 0.49 and we multiply that by 3, because there's 3 of them, what do we get?
Or 1.47.
1.47? And 0.04 times 4. I want actual calculator. What do we get? 0.04 times 4.
0.16.
1.7.
0.16. Okay, 0.09 times 2. I mean, this one's hard, there's only 2 of them, so it's hard to add up, but 0.18. And we can do our last two. 1.69 times 2 is 3.38. So there's less numbers to add. So you're less likely to make a mistake. So I'd like everyone to add these numbers up. So 2.89 plus 1.44 plus 1.47 plus 0.69 plus 0.18, or not 69, 16, and then 3.38, and then 5.29. And what do we get?
8.8.
What?
8.85.
Nope.
14.7.
I get 14.81. You should get 14.81. That's why I want you guys to do this again. Make sure you get 14.81. And whenever you're doing standard deviation, add the numbers up multiple times. Try it out multiple times. Make sure you get the same number multiple times. Otherwise, you're going to make a mistake and you're going to have a little error, and then it's going to mess up your entire paper. Okay? Then we divide it by how many numbers there are, which there are 14. which gives me approximately 1.06, and then we square root it, which gives me approximately 1.0. Okay, and what does our standard deviation mean? Does anybody remember? The average distance of the data from the mean.